Welcome to this maths video. This maths video is brought to you by Vision Concept Academy. In this video, we'll be looking at linear equations. A linear equation is an equation where the highest power of the variable is 1. For example, if we have 2x plus 5 is equals to 1, this is a linear equation because the highest power of the variable is equal to 1. That is, the power of x here is 1. X is the variable. So in this equation, you have three terms. You have the x term that has the coefficient of x as 2. You have plus 5, second term, and 1 here is the third term. In between this side of the equation and side of the equation, you have the equality sign. So we refer to the sides of this equality sides as the left-hand side here and the right-hand side here. So they are taking their names with respect to the equality sign. Now, our goal for linear equations is to determine the value of the variable that makes this equation true. That is, I will look for the number that this variable can be that will make this side equal to this side. So we can start by solving. For instance, we have this to say solve 2x plus 5 is equals to 1. We should get the value of x. The first thing we'll do is to collect like terms. Collect like terms. Collect like terms. Now we're going to be collecting on the two sides of the equation. That is the left-hand side, which is this, and right-hand side. We're collecting on the two sides of the equation. We'll collect everything, every term that has the variable x on one side, and every term that is a constant term on the other side. We talked about transpose in the previous video, transpose of equation, where we make a term or a variable the solution of the formula. So what we will do to make, first of all, make 5 come to this side, we would have to subtract 5 from both sides. We can say when 5 crosses the sign of equality with the plus sign, it becomes minus. So I say 2x on this side, on the left-hand side, is equals to, I write this one, then when plus 5 crosses, it becomes minus. It becomes minus 5. Then we have is like 2x is equals to, solve this, 1 minus 5 is minus 4. So to get what the value of x is, we'll divide both sides by 2. Divide both sides by 2. Why 2? Because 2 is the coefficient of x. So 2 can disappear from, detach from where this x is. So I say 2x over 2 is equals to minus 4 over 2. That is for dividing both sides by 2. Anything we do to the left-hand side, we do to the right-hand side. All right, so 2, we cancel 2. I have it as x is equals to 2 here, 1, 2 here, 2. That is minus 2. So x is minus 2. I define a linear expression as the value of the variable that makes the two sides to be equal. So we're going to check whether this thing we have done is equal. Is correct. So check where x is equals to 2. We're going to substitute into the expression. Okay, so we'll take it like this. We'll write the expression again. 2x plus 5 is equals to 1. So 2, instead of writing x, I put the definition of x, which is minus 2. That's minus 2 plus 5 is equals to 1. Is this true? Is this side and this side equal? Is this true? So we'll evaluate this. 2 minus 2, that's 2 times minus 2, is minus 4 plus 5 is equals to 1. On this side, minus 4 plus 5 is 1 and is equals to 1. So therefore, this answer is true. Okay, so we have introduced the linear equation. So let us quickly go further by solving further examples. So I have this, say if 6x plus 7 plus 5x minus 2 plus 4x minus 1 is equals to 36 plus 7x. So find the value of x. Find the value of x. First of all, this is a linear equation. Why is it a linear equation? Because the highest power of the variable x is 1. I don't have any power of x that is more than 1. This is 1 now, it's raised to power 1. This one here is power 1. This power 1. This power 1. So the highest power of x is equals to 1. So it's a linear expression, a linear equation. Equation because you have an equality sign where you have the left-hand side starting from here to here and the right-hand side starting from here to here. So this is a linear equation. All right. So the first thing we do when we see this, don't be afraid of this long. How many terms do we have here? 1, 2, 3, 4, 5, 6, 7, 8 terms. Don't be afraid of this train-like kind of expression that seems to be never ending. What you just do is to collect like terms. Collect like terms. Collect like terms. So what do you mean by collect like terms? Every term that has x variable, let it be on the left-hand side of this equality sign. And every term that has the constant values, let it be on the right-hand side of this equality sign. So we go. We just start from this point and move on to this point, picking them one by one. So my first term is 6x. So I write it down, 6x. I check the next term. I take this one. I'm collecting it, 5x. I go, I check, I see this one, 4x, then I'm done for this left-hand side. So I go to the right-hand side and I see that there's a 7x here, there's an x here. It equals to come and meet it. When it's crossing the sign of equality, note the sign, the operation before it. When it takes the operation with it and it's crossing, it changes. So plus here, as it's going, it becomes minus 7x. Then I put my equality sign. I start from this side again. The first one I have here is 36. So I go and look for other constant term here and bring them to meet 36 on the right-hand side. 7 is positive. When it crosses to go and meet 36 where it is, it becomes negative 7. The next term here is minus 2. Minus 2, when it crosses to go and meet the siblings, it becomes plus 2, and you have plus 2 here. And finally, minus 1 is the last one here. Minus 1, when it crosses to go and meet his siblings, it becomes plus 1. So we can now do the algebra operation for this side because I can add this side. I can do this sum on this side and do the sum on this side. So I go 6x plus 5x is 11x. 11x plus 4x is 15x. And 15x minus 7x is 8x. So I've gotten the value of x for this side. The expression for this side. Then I come here. So I can come here, I can just do 36 minus 7, which is 29. 29 plus 1 is 30. 30 plus 2 is 32. So at this point, I can now divide both sides by 8 so that x can be standing alone. Divide both sides by 8. 8x over 8 is equals to 32 over 8. So I just cancel 8 here 1, 8 here 1, then 8 here 1, 8 here is 4. That means x is equals to 4. We can check this. X is equals to 4. The value of 4 here, or the value of x here, which is 4, if you put it in this equation, it becomes true. It means that whatever I have on this side is equal to whatever I have on this side. All right, you can try that. You can try that on your own. So we can go to the next example. The next example. Okay. So we have the third example. So I have 5 open bracket x minus 1, then close the bracket, plus 3 open bracket, 2x plus 9, close the brackets, minus 2 is equals to 4 outside, open brackets, 3x minus 1, then plus 2, open bracket, 4x plus 3. So this is another lengthy kind of equation. Okay, so again, this one has brackets. So that you need to do some operations here. This is a number 3. Do an operation here to open up the bracket first, so that you can have the terms in single forms, because you have compounds like this, that's bracket, 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 bracket. The first thing you just do is just to simplify this. So what we do, open this bracket, 5 times x is 5x, 5 times minus 1 is minus 5. So I've opened this one. I open this one as well. 3 times 2 is 6x plus 3 times 9 is 27. Please be careful when you are doing this expansion. Note the signs that are coming in before the terms outside the brackets and the signs inside the bracket. The operations, if there was a minus here, when minus and plus interact, it become minus. So please just note that sign. So 3 times 9 is 27. Then this minus 2 remain there. Then open the bracket on this side. I have it as 4 times 3 is 12x. 4 times 3 is 12x. 4 times minus 1 is minus 4. Plus 2 times 4x is 8x. Plus 2 times 3 is 6. Now I have removed the brackets. I've simplified the expression. The next thing I'll do is to collect like terms. Collect like terms. Let all that the terms that have x to be on the left-hand side and the terms that are constant to be on the right-hand side. You are separating them by their surnames and you are separating siblings and siblings. Okay, so let's do this. 5x is here. The first one is 5x. Where is 5x brother in this place? The next one is 6. That's 6x plus 6x. Then I don't have any siblings for x here, so I go into this is the equality sign. I see the brother of x here as 12x. It crosses over the equality sign and becomes minus 12x. Okay, so the next one is this one, 8 plus 8x. When it crosses the equality to go and make the brothers, it becomes minus 8x. I'm done with x for this expression. I put my equality sign. The next thing I do, I start to pick the constant terms from this side. The first constant term I have here is minus 4. Please always attach the operation before the 10. Okay, so minus 4. Then the next one I have is plus 6. One by one, I go back again here and begin to pick the constant term. Minus 5 crosses to go and meet the brothers there. It becomes plus 5. And I have 27. Plus 27 cross to go and meet them there is minus 27. And minus 2 cross to go and meet them there, it becomes plus 2. Now, having gotten to this stage, I will now simplify the left-hand side and the right-hand side. So let's go. 5x plus 6x is 11x. 11x minus 12x is minus x. Minus x. So minus x minus 8. Minus x minus 8 becomes minus 9x. Minus 9x. That's for this side. For the other side, minus 4 plus 6 becomes plus 2. Plus 2 plus 5 becomes plus 7. 7 minus 27 becomes minus 20. And minus 20 plus 2 becomes minus 18. So I am now left with just detaching 9 minus 9 from x. How do I detach 9 from minus x? So how do I detach minus 9 from x? I'll just simply divide both sides by minus 9. So minus 9x over minus 9 is equals to minus 18 over minus 9. Minus 9 cancels minus 9. Minus 9 here 1, minus 9 here 2. So x is equals to 2. So the value of x equals to 2 will make this expression true. You can check. Just put this value of x is equals to 2 in this expression. Wherever you see x, you just put 2. This side of the equation must balance with the side of the equation. That is why this one is correct. So we're moving up ahead and we'll look at fractional cases of linear equation. Okay, so what if they now bring in your exams fractional linear equation? What do you do? So this example, I will call it example 4. Example 4. So I have a fractional expression here, x plus 2 over 2 minus x plus 5 over 3 is equals to 2x minus 5 over 4 plus x plus 3 over 6. So they say we should solve this equation. Solve this equation. First of all, it is linear equation. Why? Because the variables of the equation, that is x, their power is 1. None of them exceed 1. So we said a linear expression or a linear equation is an equation where the highest power of the variable is 1. Our task is to look for the value of x that makes the equation true, that makes this side and this side to be equal. So how do we do it? Now we are looking at this equation. It is all in fraction. This term is a fraction because it has upstairs and downstairs. What do we call upstairs and downstairs in mathematics? Fractional cases. You call this upstairs the numerator, and the downstairs here you call it the denominator. So every term have numerator, denominator, and so on. So I have 1, 2, 3, and 4 terms in this equation. What do? The first thing I do is to make it in linear form, that is in a non-fractional form. Yes, convert it to non-fractional form. Let all these ones downstairs disappear. So I'll inspect first. I'll look for the least number that can divide these numbers without any remainder. The least number that can divide each of these numbers denominator without any remainder. 2, 3, 4, 6. The least number should be 12. That is like the LCM. So if the LCM is 12, if the LCM is 12, I will now say multiply each term by 12. Multiply each term by 12. The goal for this kind of thing that we are doing is to cancel out these denominators. So I will say multiply each term by 12. So this is the first term. So I'll put 12 outside. I will open a bracket and put the first term. This is the first term. Nothing changed. I just did. And as I'm doing this 12 here, I'm running it throughout all the terms. I'll put my minus again. I'll put the same 12. Open bracket, x plus 5 over 3. This is second term. The third term too, the same thing. I'm not cheating anybody. I'm giving them 12, 12. 12, 12. I'm giving them 12, 12. No cheating. I'm not giving this one 12. I'm giving this one 4. I'm multiplying each term by 12. So how does it go? From the bottom here, 2 is 1, 2 is 6. So here I have 3 here is 1, 3 here is 4. Write this your calculations clearly so that you don't miss anything. 4 here is 1, 4 here is 3, small 3 outside. And 6 here is 1, 6 here is 2 outside. So what I will do now, I will now open up the brackets by what I have outside the bracket. So 6 times x is 6x plus 6 times 2 is 12 minus 4 times x is 4x. Now note what I've been singing since. This is minus here. So minus 4 times plus 5 becomes minus 20. You see, minus plus is minus. Please note that. Because the dynamics, once this thing, you don't get it right, it changes everything about this equation. Okay, so the next one is 3 times 2 is 6x minus 3 times minus 5 is still minus 15 plus 2 times x is 2x and 2 times 3 is 6. At this point, I will collect like terms. The brothers that are x will come here, and the brothers that are constant term will go the other way. So I'll start from the first term and start collecting. So I have my 6x here, So I look for the next brother, that is minus 4x. I look for the next one, no one here. So I'll go over the equality sign. I'll go and pick minus 6 here, 6x here, yeah. So when 6x cross the equality, becomes minus 6x. And when 2x plus 2x cross the equality sign, becomes minus 2x. I'm done with all the x from the left to right. So I put my equality sign. I start with the constant term from this side, minus 15 plus 6. So I go and start again from here. Plus 12 crossover, it becomes minus 12. And minus 20 crossover, it becomes plus 20. At this point, I can now do the algebraic sums. So 6x minus 4x is minus 2x. Sorry, no, not minus 2x. Sorry, I start again. 6x minus 4x is 2x. 2x minus 6x is minus 4x. Minus 4x minus 2x becomes minus 6x. If I'm too fast, I take it again. 6x minus 4x becomes 2x. 2x minus 6x becomes minus 4x. Minus 4x minus 2x becomes minus 6x. So I'm done with the left-hand side. To the right-hand side, plus minus 15. Minus 15 plus 6 becomes minus 9. Minus 9 minus 12 becomes minus 22. Minus 22 plus 20 becomes minus 2. So at this point, I would look at it again and see what I have not done. Hold up, let's look at it again. We are done. Let's look at it again. I've created like terms. Okay, so this is it. This is 4. This is 6. This is 2. Okay, so in all of this, if this one cancels this one, 0. Yes, this is correct. This one is 20, 15, 6, 12, and 20. Okay, so this is 26 minus 15. Okay, let me be sure of this side of the equation. Minus 15 plus 6 will give me minus 9. Minus 9 minus 12 will give me this is 1. Minus 9 minus 12 will give me minus 21. Yes. Minus 21 plus 20 will give me minus 1. Okay, so I thought there is something wrong with this equation. So this is minus 1. So I'm going to divide both sides by minus 6. So you see how you have to be careful. I won't have to edit this part because I want us to know that we are humans. If you suspect that you are not getting it, you just check. You just check. All right, so please check, always check. So I have divide both sides by minus 6. So we have minus 6x over minus 6 is equals to minus 1 over minus 6. So cancel. So I have x is equals to 1 over 6. So 1 over 6 is the value of x that makes this equation true. So I've given you some range of examples. Sometimes in linear equations, you can even have a word problem that will cumulate into this linear expression. I will encourage us to do a lot of practice. Mathematics is practice, hands-on. Do many examples, many exercises as possible so that you can get used to the linear equation. And I wish you all the best of luck. Thank you for watching. Please like, subscribe, and even comment on this video so that we'll have people even have to watch it. Thank you for watching this video, and I would like to wish you a great day.